I have gotten notices from at least 5 or 6 different people that I know them personally. They may not be like good friends of mine, but I know them personally that I have not come into contact with, for the record. But 5 or 6 people who have tested positive, just in the past 2 weeks. Obviously, like hospital usage is up. I think the last thing I saw was like in Ocean County, all the hospitals in Ocean County, their ICUs are like 80% capacity or more or something like that. I know. That Cali score is going to come out today at some point, the new Cali score. And like I said, I'm pretty sure it's still going to be a 3, but we'll see what happens. I don't know. Oh, the Cali score, the COVID awareness level index or something like that. It's basically... Oh, yeah, you did. It was based on a 1, 2, 3, 4 scale. And right now, New Jersey is a 3, which indicates that, yes, we have to take these extra precautions, but we don't have to go fully virtual if they take these precautions. You know what I'm saying?
What's fully virtual for?
Yes.
Like there's no option?
I believe, now don't quote me on that, but I believe that we have to, yes, if we hit 4. Now, it's very difficult to hit a 4 because you have to have, there's like 3 separate categories, and you have to have a 4 in at least 2 of the categories and a 3 in the other. So right now we're 4.32, which averages out to a 3. And with the new Cali score coming out today, I believe it'll be 4.33, which 3.3 is what the average is, but it'll round down. In order for it to be a 4, it's got to be at least 4.43 or straight 4s across the board. So, yeah, Cali scores. Anyway, here's what I'd like to... No, that's what they've been measuring like pretty much all year. The Cali, the COVID Cali score. Yeah. Anyway, here's what I'd like to do today. I would like to wrap up some things that we're going to deep dive in regards to probability. It's going to be nice. I do have some things that I would like to get to in regards to playing poker, but I'm going to save that for a little bit later. But, and just to give you guys the heads up, at approximately 7:30, an assignment on Google Classroom will be made live to you. And that assignment is going to be an online quizzes minor. Now, that online quizzes minor, you will have 2 attempts to get it done. 2. Obviously, the higher score is the one I count, but that would be terrible, But now notice the due date. Now you can't see the due date right now, obviously, because it's not live to you. But I'm assigning it today, Thursday. I made the due date for Saturday at 2 p.m. I made it for Saturday because I wanted to give you guys just a little bit of extra time just in case. My hope is that we would be able to get in an attempt during this particular class period. And I would give you the option of that in the last little bit of class. But, and this is a huge caveat that I have for this whole thing, if I'm going to be giving you an online minor, I want to allow you to have the time, obviously, to get that kind of thing done. On quizzes, when you take certain quizzes, do they allow you the option sometimes to save and exit? Yeah, I've never seen that. Okay, that's fine. Sometimes they do that depending on certain settings that are set, but I'm not going to risk that. So at a certain point, I'm going to decide, okay, there is enough time to kind of fit in an attempt if we so choose to kind of do that. But otherwise, I'm going to allow you to save your 2 attempts, for obviously after class or before Saturday, things of that nature. But that'll be due by Saturday at 2:00. Anyway. So what I would like you to do, and I got to get you a copy because you weren't here, but I want you guys to dig out that worksheet that I gave you last time on probability, the one with the ham and turkey problems at the top. Dig that one out for me. What's up? Not exactly at the moment. But obviously, if we do that attempt later on, then sure. But that remains to be seen. I want to make sure I get through what I need to get through first and make sure you have plenty of time. For those of you in the chat, this particular PDF, of course, is available in the Google Classroom stream. I made the PDF available the other day. Let me see if I can't copy and paste the link. Yeah. Let's see. Copy link. And paste. Boom. There we go. Meanwhile, I'm up at like 4:30, and I'm like, hey.
Oh, I'm normally up at 4:30.
Anyway, we'll bring this thing back here. Put this thing in here. Let's see here.
No. You don't know.
Who? Him?
Yes, sir. Not today. Okay. I did it for like 5 months. 5 or 6 months. I did. You want to give me one? You want to give me one? So why'd you say you're going to give me another one? I do want one.
This conversation's gone off the rails now. Now you just guys are like arguing in a circle. You know. All right. So I'm looking back at number 2. Now we finished up with number 2 last time. I do want to get to number 3, which we're going to talk about in a little bit. Number 3 is we're going to have to do a pretty big deep dive on number 3. But I want to talk about number 2. We did start this problem last time, and I just want to make sure that we actually do what it's actually saying and do something a little bit different with it. It's going to be nice. Many school administrators watch enrollment numbers for answers to questions parents ask. Some parents wondered if preferring a particular science course is related to the student's preference in foreign language. Students were surveyed to establish their preference in science and foreign language classes. Does it appear that preferences in science and foreign language are independent? Explain. Last time, we did this problem using, I believe it was chemistry versus French, in order to determine whether or not the two events were independent of each other, the events being the type of science class that you choose and the type of foreign language that you choose. It's really crazy. But I want to go a little bit deeper with this. To remind you, where'd that marker go? Oh, the marker died on me. Yeah, I threw it in anger, so I'm going to use this one. To remind you, if, and then we have this written into our notes, if the probability of B is approximately equal to the probability of B given A, then A and B are independent. That is the basics that we covered last time, but we kind of deep dived that a little bit. Pick one of the sciences. Doesn't matter what it is. Biology? Sure. Let's pick biology. So, I want you guys to do the following. I want you, and write this, you can write this directly on the paper if need be, of course. I want you to figure out first, what is the probability of Spanish given biology? I just want you to think about that for a moment. Look at the chart. Look at what they gave you. And write down the fraction that you believe is the correct fraction to answer that question. Obviously, we'll figure out the decimal later. Good morning. I'm waving. I'm waving to the chat. Just as a reminder for the given statement, when I say given biology, given I am only looking at bio students, given that I am limiting myself to just students in biology, given that biology is already a choice that has been made, what is the probability that Spanish is the language that's being taken? What fraction do y'all get? So you got 35 over 44? All right. And what did you say? 44 over 52? 44 out of 102. We got 3 different answers. Anybody else? Yeah? 102 over 52. Got 4 different answers. Well, they're all coming from the chart. Every number that you guys gave me came directly from this chart. Yeah. Well, I mean, the ones that they told me, you know. This is good. Oh, there. So I think someone said that number too. Did someone say 44 out of 52? Yeah, in the chat, she said that as well. So that's why. She agrees. I don't know. Let's just see what happens. Well, let me repeat what I said, and then I'm going to draw something on the board. Ready? Given biology, given that you're only looking at biology students, given that you are only limiting your scope to that category that I just put in that box. Independent, yes. Well, you're only looking at the 52 students who take biology because of the given statement. And now they're saying, what is the probability that out of those 52, they take Spanish? You're limiting yourself to just the given statement. It is 44 out of 52. It is 44 out of 52. And again, the decimal, we can figure out the decimal in a moment. But when you have that kind of given statement, that's what you are limiting yourself to. It's 44 out of 52. Which, I don't know, just for the sake of argument, let me just kind of jot down the decimal over here. 44 out of 52. 0.846. 0.846. It's always good to kind of have that decimal there. But it all depends on the given statement. It all depends on the given statement. Cover that up. There we go. So now watch this, because this is really going to mess with your heads. It's really going to mess with your heads. What is the probability of biology given Spanish? See, now, obviously, I flipped the words. It is going to be a different answer. See, because when I flip it like that, you are changing the given statement. When I change the given statement, you are changing the initial group of people that you are looking at. What do y'all think? In this case, it would be 44 out of 102. Because since you are limiting yourself to just Spanish students, you are limiting yourself to just the group of people who take Spanish, then you are limiting yourself to just that category in the chart. Given that they take Spanish, given that you're only looking at Spanish students, what is the probability that out of those 102 Spanish students, they would take biology? 44 out of 102. It changes the denominator, obviously, which is what, 0.431. Now, again, the wording on these questions is so unbelievably precise. The wording on these questions is so unbelievably precise. What if instead I asked the following question? What is the probability of a randomly selected student taking both Spanish and biology? What is the probability of a selected student taking Spanish and biology? Now, this is a different story. Now, we had this conversation last time a little bit. And does imply multiplication, yes. but we're not quite certain whether or not it's, independent or dependent at the moment. What are you thinking? In this instance, yes. If now, again, the symbol in the middle means everything. When I have that given statement, I've explained hopefully what that given statement does. But if I'm talking about, okay, randomly select student, what's the probability that they take both? There are definitely 44 students who take both. There are 44 students who take both Spanish and biology. But because it's such a broad question like that, okay, just in general, Spanish and biology, no givens, no bells or whistles. Yes, 44 out of 136. Because that would be out of everybody. That would be out of everybody. And again, notice, it's just the bottom of the fraction. The bottom of that fraction keeps changing. 0.324 is what it rounds to. Yes, 0.324 is what it rounds to. Depending on the question that I ask, it just changes the bottom of that fraction. The bottom of the fraction for the most part. It's a little weird. Okay. Now, this is the question that I'm going to give you a couple of minutes, not a minute, a couple of minutes, maybe a minute or so, to try on your own. This might mess with your heads a little bit. This might mess with your heads a little bit. In fact, I'm going to put it in I'm going to put it in a different color. I'm going to put it in green because I want it to stand out. The probability of Spanish or biology. The probability of Spanish or biology. I want you to take a minute. I want you to consider what that question is asking. And I want you to figure out what the answer should be. Take a minute. Be in your own head. Oh, sorry. Does anybody have a fraction for me? What do you got? Okay, I'm gonna start. If we do get different answers, I'm gonna write yours up here, and I'm gonna write everyone else's as well if they have different answers. So you're saying 110 out of what now? 136. Okay. Anyone else have an answer? You had 102 out of 136. You have a second in? No, I'm kidding. Yeah. Sure, tell me what you got.
Okay, well, I got 79 and 136.
79 out of 136. Okay. She says 52 out of 102. Last chance. That one's up there too. I will tell you, only one of these is correct. One of these is
One of
correct.
those answers is correct.
One of those four is correct. Only one of the
So
four.
Andy, you should pick like
Yep.
Yeah.
Here's what it comes down to. Here's what it comes down to. The probability of A or B,
I think 52 might be the answer.
this one,
Yeah.
is the probability of A plus the probability of B minus the probability of A and B. Ah!
Oh, wow. Just what I want. Thank you.
That is the formula. That is the formula that we need to use in order to calculate the probability of A or B. You take the probability of A, you add the probability of B, and you subtract the probability of both. Whenever you hear that word or, you're supposed to be thinking adding, subtracting. Yes. Well, let's just look at it a step at a time. The probability that someone is in Spanish plus the probability that someone is in bio, minus the probability that they are enrolled in both. That is what the formula is telling us to calculate. Well, the probability that someone is just flat out in Spanish class. Hey, how many kids are in Spanish class? 102. The probability that someone is in Spanish class is 102 out of 136. Plus, what is the probability that someone's in bio? 52 out of 136, yeah. Minus, what is the probability that they are in both Spanish and bio? Second? Yeah, we got that earlier up here. This was the probability of Spanish and bio. It was 44 out of 136. If you do that correctly, it's that one. Oh, sorry. I know. I know. But it is 110. Say again?
You got that.
Steve did. Yeah. It is 110 out of 136. It is 110 out of 136.
Did you know the answer before you did it?
Me?
Yeah.
Oh, yeah. I did it right here. Yeah.
You can do it.
It's a calculator.
Yeah.
That's 0.809. I always like to convert them into the decimals just because it's easier to compare fractions when you convert them into the decimals. But from this one table, just talking about Spanish and bio, you can find the probability of Spanish, the probability of bio, the probability of Spanish and bio, the probability of Spanish or bio, the probability of Spanish given bio, or the probability of bio given Spanish. Right? Just from those two things. But it all depends on the wording of the question. It all depends on the wording of the question. You always have to pay attention to that kind of thing. It's really strange, really weird. I know. So, yes. Here's the fun fact. It's a good question. Here's the fun fact. You know how I tell you guys that this is like AP Light? Oh, by the way, just for the sake of argument, for the people in the chat, the question that was asked was, will we have to memorize all these formulas? In AP Stat, they do give you on the AP test a formula sheet, but that formula sheet doesn't have a ton of stuff. In fact, let me show you what that formula sheet actually looks like. Let me erase this junk, because I was going to erase this anyway. Like a little bit early. That's okay, though. So let me show you the 2020 AP Stat. I don't know if they'll actually have it here. Let me go 2019 then. Here we go. So I know it's a little difficult to see, but on the board right now is like a ton of formulas in regards to AP Stat. Now, these formulas are kind of like redundant. Like literally, this formula at the top, do you know what that formula at the top's actually telling you? It's telling you how to take an average, which clearly you know how to do. Say, add them all up, divide by how many you have. Done. Cool. The second calculation, that S, you know what that S stands for. It's the standard deviation. That's how you would actually calculate standard deviation. But, besides that, let's scroll down a little bit. Those are linear regression equations, blah, 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 blah. Oh, look, probability. My plan was to tell you what that was in our notes. That was my plan. But these are the two main probability formulas that they give you. This is the probability of A or B, which is the probability of A plus the probability of B minus the probability of A and B. Yeah. Yeah. They still obviously, they still have the symbol for given, which is it's a similar formula to what we've done. It's, we wrote this down last time. I'm going to do it again. But the probability of A given B, now mind you, it's given B. They actually flip the letters. A given B is the probability of A and B divided by the probability of B, which in this case was, again, the given event. Those are the two main probability formulas that they give you on the AP test. So, to answer your original question, if you were to take something in class, yes, I would provide you with whatever they give you on the AP test. So you would have those formulas, at least those two, which is nice at the very least. Oh, no. They do give you more down here, but these are like stuff that we may or may not get to at one point or another. Actually, we may get to binomial geometric. I haven't decided yet. And then believe me, we're not going to get to we're not going to get to hypothesis testing and all of these formulas down here. We're not going to get to that. But that's just another thing entirely. Anyway, here's what I'm going to need. If you do not already have them out, I'm going to need those notebooks out and open. It's interesting. Every year when they take the AP test, they usually take the test in a classroom with all of their classmates. So there's like 20, 30 kids in the class. Last year, they couldn't do that. So for the AP test, they took it online, which, online, everybody could use their notes. Everybody could look up whatever they want to look up. Well, what's nice about it is that the AP graders, the AP test people, they made the assessment in such a way where these questions, if you tried to search them, you would never find them because they had never been on the internet before. And they decided, well, we'll make a test where it doesn't matter if they have their notebooks or not. I know it is. It really is. But they had to. They had to. You have 200,000 students all competing for college credit. And when I say competing, I really do mean competing. Because only the top 60% get to pass every year. Only the top 60%. It doesn't matter how good or bad it was. It matters on whether or not you were in the top 60%. You what?
I'm in the top 60%.
Of what? Oh, okay.
Whatever you just said.
Nice. Whatever I just said. Taking the AP test.
Mm-hmm.
Today's the 10th. Come on, Cali score. Where's my Cali score at?
What, it's supposed to come out soon?
Today. The Cali score comes out every week.
Really?
Every week, yes. Probability, continue.
Every week on
Thursday.
Thursday?
Yeah. In fact, hold on. I have the link saved right here. Yeah, they only have it up the last Cali score. This is what the Cali score shows you. We're right here.
Central East.
Yeah, Central East, what I just highlighted at the bottom there. You can see our Cali scores.
Oh, it goes up to a 6.
Kinda. It goes up, not exactly up to a 6. It's a footnote explaining what the Cali score is. But that's another conversation altogether. Okay. Probability continued. First and foremost, the probability of A, what's the symbol B? This symbol should be read as, quote, or. That symbol should be read as the word or. They use that symbol to represent the union between two events. And when I think of the union between two events, I think of a Venn diagram, per se. It's a little strange. I know. Because with like a Venn diagram, you could have but you could have stuff in the middle too, and that's like the and. I know. And then no pun intended, but on the flip side, you have this symbol. And this should be read as and. That should be read as and. Now, typically, I don't use those symbols. When I have the ability to write out problems, I usually use the words or and. But I just want you to be aware, and that was kind of part of what I was going to do today. I want you to be aware that if you ever see those symbols, that is what those symbols are referring to. And again, depending on what the question is asking, I know. I know. But depending on what the question is asking, we just have to be ready to act based on what they're asking. Like I said, with that table, they could have asked any number of things, like the or, the and, the given, and we did it all. A little bit, but here's the thing. It's like, let me give you an example. You all know what the symbol pi looks like, correct? Do you know what the symbol pi represents? Well, you would have to keep reciting numbers forever in order to be correct. That's the value that it represents, but what is it? More, I need more. The circumference. I need more, though. No. It's the ratio. It's the ratio. By the way, you were wrong on some of your numbers. 3.1415926535. Yeah. Anyway. Yeah. Yes. Of course. Pi is the ratio between the circumference of the circle and the diameter of the circle. That's the ratio. It's the fraction, the circumference divided by diameter. Now, back in the day, mathematicians would literally, when they needed that value that he was trying to recite, when they needed that value, they would literally write out the phrase, the ratio of the circumference of the circle to its diameter. They would literally write out that phrase every time. So if you read like old mathematical papers back in like the 1700s, you would see that full phrase if they were using that as a value. It wasn't until the 1800s that someone's like, why don't we just stop writing that phrase and use the symbol to represent it? And now today, it's like you guys just know the symbol. I don't know. Mathematicians aren't that creative. They aren't that creative. But when they are, they are. Anywho. Okay. Check this out. We're going to do a deep dive on number 3 on that worksheet, and I want to put it in our notebooks. We're going to do a deep dive here. As this information is coming out, I'm going to write this information directly into my notebook. So I'm going to suggest that you do the same as well.
That's the whole problem.
No. Don't write the whole problem. Write the proper information that I'm going to tell you to write. You'll see. But just for the sake of argument, I'm going to write down example number 3, just so I have that in my notes. For purposes of making budget plans for staffing, a college reviewed students' year in school and area of study. Of the students, 22.5% were seniors, 25% were juniors, 25% were sophomores. By the way, did you ever know that sophomore has an extra O in the middle of it? Look at it. Look at the word.
Yes,
Sophomore. Look at it. It's on the paper.
That's crazy.
I know. Anyway, and the rest are freshmen. Also, now, this is where it gets a little dicey. Also, 40% of the seniors major in the areas of humanity, as did 39% of the juniors, 48% of the sophomores, and 36% of the freshmen. What is the probability that a randomly selected humanities major is a junior? Show your work. Now, it seems at first glance like, okay, numbers. That's a lot of junk up there. I'm going to do something that I don't normally do. Oh, no. I am going to give you the answer, and we have to figure out how to get there. I'm going to give you the actual answer to this problem first, and then we're going to work towards actually getting it. The actual answer to this problem, I'll write it up here, is the decimal 0.2523. It is the decimal 0.2523. The question then becomes, how do we get there? There's a lot of information that's being floated on this problem. It's a lot of information. First, they're talking about the grades that these kids are in. And then they talk about this whole 40, 39, 40, and 36%. Then they throw in the extra letter of O in the middle of sophomore. What the heck are they doing? When I was in high school, actually, you know how like you guys make like a class banner sometimes? The sophomores once did a class banner and then forgot to put the O in there. It was unfortunate. We kind of made fun of them. Anyway, stupid sophomores. Anyway, let's write down some information. First of all,
You don't like freshmen either.
that's true. Stupid freshmen. Let's go hunt them down. Anyway, the probability.
You don't like
Stupid seniors. Anyway,
you.
that hurt? The probability that someone is a senior is 0.225. The probability that someone is a junior is 0.25. The probability that someone is a sophomore, I'm just going to put soph, is 0.25. And they said the rest are freshmen. So it's like, okay, what should all of that add up to? Should add up to 100%. So it's like, well, it will once we put in the proper number for freshmen. Should be 0.275. It said the rest are freshmen. So yes, it has to be 0.275 in this case. So yeah, there's more freshmen coming in. There's less seniors going out. I know that tends to happen from time to time. Okay, that's the initial information they've given us. Now look at that next sentence. 40% of the seniors major in the areas of humanities. Say again? Who? Oh. Okay. You'll never be lonely. Yeah. 40% of the seniors major in humanities. 40% of the seniors. If you only looked at the seniors, 40% of them would major in humanities. 40% of the senior class are humanities majors. What is that sentence really saying? There's something that I'm really trying to imply about that sentence, and I can't leave it alone. If I only look at the group of seniors, if I just had seniors in the room, all the seniors in the school, just in this room, 40% of them would be humanities majors. There's a word, a 5-letter word that starts with G that I need to use here.
Great.
That is a 5-letter word, but not the word I need. Given. I need the word given. That sentence, 40% of the seniors, 40% of the seniors are my given event. What that's really saying is this: the probability that someone studies humanities, given that they are a senior, is 40%. That's what that statement is actually saying. We need to recognize that. 40% of the seniors means given that you're only looking at seniors. It goes on, as did 39% of the juniors. The probability of being a humanities major, given that you are a junior, is 0.39. Humanities, here, I'll show you. Because it's a list of things. List of humanities majors. Boom. The humanities are English literature, modern languages, history, and philosophy. Yay!
That doesn't sound fun.
Say again?
That does not sound fun.
It's what they chose to do.
What do you become with a humanities major? Like any one of those
Well,
subjects?
based on that, I would say unemployed. No, I'm joking. What? I'm joking. I'm sorry. That was mean of me.
No,
That was mean of me.
the thing is you're not doing. That's the thing.
No, there's plenty of things that you can do. If you have a bachelor's degree, you are much better off at getting a job than you are if you didn't. You know what I'm saying? Just saying. If you have vocational degree, you have a much better job. If you have any type of post high school degree, you do have a better chance. But anyway, oh, this guy says they're all laughing. So
How's it going?
anyway, the probability that someone is a humanities major, given that they are a sophomore, according to this, is 40%, and the probability that someone is a humanities major, given that they are a freshman, is 0.36. Now, here's the big question. They gave you all of this information in that paragraph. Now, we need this information. As I said, we were going to do a deep dive on this problem. We need that information. Here's the question now. And again, you have the worksheet in front of you. You have the worksheet in front of you, but I want to read this question very deliberately. And then I'm going to write it down up here. What is the probability that a randomly selected humanities major is a junior? Now, I want to be very clear about something. Look where I'm pointing. This, what I'm pointing at, is randomly selecting a junior and the chance of them being a humanities major. Let me repeat that. What I'm pointing to right here is the chance that you randomly select a junior and they're a humanities major. This problem is saying you're randomly selecting a humanities major and they're a junior. It's reversing the problem. It's reversing the probability. That is what it's doing. I'm going to alliterate something on the board in a moment with a picture. But let's just see what happens here. Here's the actual question. The question is that. That's what they're actually asking you. That is what they're actually asking you. Where's my green marker? I must have thrown it in a fit of rage. Oh, no, it's in my pocket. Cool. That's true, but I may have done it in my heart. So here's humanities majors and here's juniors. Here's humanities majors and here's juniors. Now, obviously, with this whole given event, given that you are only looking at the juniors, what are the chances that the person would be a humanities major? That's what that 0.39 is. The probability that someone is a junior given humanities is the exact opposite of that. It's given you're only looking at the humanities right here, given that you're only looking at the humanities majors, what are the chances that they are a junior? See, in the junior class, you fall into one of two categories. In the junior class, you are either a humanities major or you're not a humanities major. Those are the two options. Among the humanities majors, you could be a freshman, sophomore, junior, senior. This question is very nuanced. And we're going to need something special. Something special that you have never seen before. We're going to need to draw a tree.
Just one tree,
We're going to draw a tree.
singular tree,
Kinda. What do trees have?
branch.
This tree is going to have branches.
Oh,
We're going to draw a tree.
no, not all trees have leaves.
That's true.
No, it's not. No, not all trees don't have leaves.
Are you talking
All
about
trees don't
plain
have
naked
leaves.
branch trees?
Question.
Hey, it's not a leaf. It's a bud.
Question.
Needle.
What determines whether or not... Hold on, Andrew. What determines whether or not a piece of fruit is actually a fruit? How do you determine if something is fruit? If it has seeds in it, cucumbers have seeds.
So you think cucumbers are fruit?
No, I'm just saying, don't cucumbers have seeds? Don't pumpkins have seeds?
Here, wait. I have-
No, it's not.
A pumpkin is not a fruit.
What's up?
Okay, so like I think of like fruit as like sweeter, right? Like a more like a kind of like a candy sweet taste, and then I feel like vegetables is like a healthy taste, because that makes sense. Anyone yeah. I'm like not really.
Well, here's actually what it comes down to. Would you like to know?
Yeah.
When trees grow, certain trees produce what is known as a fruit. So when the tree actually blooms, that bloom is called the flower. And then what comes out of that flower is generally considered to be the fruit. Okay? Yeah, that's literally what it is. So there are certain things that you might not consider to be fruit that actually are fruit. Now, you talked about tomatoes. Yes, now technically, tomatoes are the fruit of the bloom. Because if you've ever seen a tomato plant grow, it has to do that little bloom first of a little flower on the vine, and then it grows the tomato. Why do you think tomatoes usually have that little green thing at the top? Because it came out of the flower. You think about that. No, pumpkins are technically gourds.
Just fat gourd.
Yeah. Anyway, back to this.
Just like
Oh, actually, she might be right. Sky says that pumpkins might be classified as berries, and that actually might be a good point. Yeah. Anyway, back to this.
Oh,
We're drawing a tree.
berries.
some berries are fruits. What berry is a fruit? The one that I said.
Anyway, here's what I draw first. First of all, you have senior, junior,
Oh, I thought we were going to draw an actual tree.
sophomore, freshman. Well, we're drawing a probability tree. And on this one, it's 0.225, 0.25, 0.25, and 0.275. And if you are a senior, given that you are a senior, if you choose amongst the seniors, you are either a humanities major or you're not. And I'm going to write the word other. Point 40, point 60. Let's pause there for a moment. Pause there for a moment just so we can see what's being drawn up here. This tree is going to take a little bit of time to get into to explain. But once you get the hang of it, these trees won't take that much time. But this is the first time you're seeing it. First, we did the class that you're in, senior, junior, sophomore, freshman. And those are the probabilities that they gave you in the problem. But then they said, of the seniors, 40% are humanities majors. Of the seniors, 40% are humanities majors. So if I go down the senior branch of this tree, the senior branch then splits into either humanities majors or not humanities majors. That's the 40%, and there's the 60%. Then juniors does the same thing. 0.39, 0.61 for humanities majors versus other. Same thing with the sophomores. Sophomores, 40% go humanities, 60% go other. And of the freshmen, 36 go humanities majors, and that makes 64 go other. That's what these things do. This tree will help us eventually get to this answer. This tree will absolutely help us get eventually. Well, it's going to be next class. Yeah, unfortunately. I know. Here's the thing. This information is not needed on that minor that I have for you. Remember that the quizzes minor that I have? This stuff is not needed on there. The tree. Because I knew it was going to take multiple class periods to get into. I plan ahead. I do. Anyway. Now, what's nice about this is that when you go down the branch, you are automatically declaring what given statement you are making. So, for example, name a class other than senior. Junior. Okay, check this out. If I say the probability of other given junior. If I say the probability of other given junior. When you say junior as the given event, you are telling me that you have already gone down the junior branch. So if I go down the junior branch, what is the probability that the person is an other major? What's it say on the tree? 61%. Yeah, it is. But that's what the tree says. That's exactly what it does. Now, here's the problem, though. The question that they're asking us, and this is what I'm going to wrap up with today. The question that is being asked on that problem is, what is the probability that you are a junior given humanities? Here's the problem, though. Which branch do you go down? Because according to what I just said, you're supposed to go down the humanities branch, but you're starting here. You can't jump a branch. Kind of. What's going to end up happening, and I'm going to talk about this next time, what's going to end up happening is we are going to have to go down this branch, this branch, this branch, and this branch in order to eventually get that answer. So I said I knew it was going to take multiple classes. I know, it's so amazing. I'm so excited. You totally could just jump, just saying. I know, I probably could. Anyway. Hold on, now I got to look it up. What are pumpkins classified as? Are they berries? Pumpkins. Berries? A pumpkin is technically a berry. She was right. The word berry is defined as a simple fleshy fruit that usually has many seeds and actually encompasses a whole lot more than you may have previously thought. Can you name the only food that has seeds on the outside? Yeah.
Yeah, baby.
Have you ever tried to remove its seeds? Oh, it's funny. That's really funny. I like it. Yeah. Yes, I did announce that to the class. Anyway, so do not forget, there is an online quizzes. Now, like I said, you have 2 attempts at it. I had hoped to get in 1 attempt today, but obviously there wasn't enough time and I didn't want to force it. So you have 2 attempts. It is due Saturday. Use your probability notes if you need to. The probability tree is not on there, obviously, but the rest of the stuff is there. Let's get them done. I'm going to sign off this stream. I'm going to call it a day. Boom. Make sure you try to